Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we'll continue further with Mathematics Class 11th. The chapter that we're dealing with is Introduction to Three-Dimensional Geometry, and now is the turn of exercise 12.3. Now 12.3, this particular exercise is based on concepts related to section formulae. In the previous two exercises, we have seen some basics about the coordinate system. In the second exercise, we saw distance formula, and this exercise is based on section formula, and that's all that you need to study in Introduction to Three-Dimensional Geometry. There's another chapter in your class 12th that is three-dimensional geometry, which we'll be covering soon, and that actually advances you further with more knowledge of three-dimensional geometry. Equation of line, equation of plane are covered over there, right? So now is the turn of section formula, and that's the only thing that you need to study for this particular exercise. Very simple concept. Yes, internal division, external division are two important things that you need to take care of. Otherwise, things are very simple, right? Once you are aware of the coordinates, you can find the ratio between, right, any two segments, and once you're given, let us say, the ratio, you can find the coordinates of any middle point, right? That's what you can do. So along with the questions, we'll be seeing the concepts, right? Let's move on to the first question. The first question says, find the coordinates of the point. A direct question for that matter. Find the coordinates of the point which divides the line segment joining the points this and this in the ratio 2:3 internally, 2:3 externally. That's what the question says. A pretty simple and a direct question. Let's say we have 2 points A and B. The coordinates of A being x1, y1, z1. In three dimensions, the coordinates will be x1, y1, z1. This will be x2, y2, z2. Okay. And if we want coordinates of any particular point P, x, y, z, which divides this in the ratio m is to n. This part is m, this part is n. So how will we find this point P? So point P, the coordinates will be x, y, z will be equal to mx2 nx1. Just cross it, right? So mx2 plus nx1 upon m plus n. This is the value of x actually. Then you have my2 plus ny1 upon m plus n, and then you have similarly mz2 and z1 upon m plus n. These are the coordinates of this point P, as you can see over here. Is that okay? Yes, that looks pretty much okay. Another point would be you can say there could be another point Q over here. And this Q, for this Q, we can say that AQ, this is m is to n. Okay, what are we saying? In the first part, we say that AP upon PB is equal to m upon n. In this part, it says AQ, for external division, AQ upon QB is equal to m upon n. If this is the case, then point Q divides AB externally in the ratio m is to n. And in such a case, the coordinates of Q can be obtained by making a small modification over here. That modification for the coordinates of Q, let Q be x prime, y prime, z prime, let's say. So the values of x prime, y prime, z prime can be found easily with this result. What are we supposed to do? M times, M is associated with A and Q. M is associated with A basically, right? M starts from A. So you take M with the coordinate of B, mx2. Okay. Then N is associated with B. You take N with x1. Basically, we are crossing. In a similar manner, what we did over here, mx2 n x1. Similarly, we'll do mx2 n x1. Mind you, crossing, right? That's what we were doing. mx2 minus nx1 upon m minus n. This is what you'll be doing. The y coordinate that is y prime will be my2 minus n y1 upon m minus n, and the z coordinate will be m z2 minus n z1 upon m minus n. This is what you'll have, right? So point Q, where will point Q lie? If I want to ask that question, where will point Q lie? That question can be answered with the help of a simple idea. What's that? That if m is greater than n, then for internal division, the point right lies on the right hand side of the middle point, right? And if m is greater than n, can you observe that the point Q lies for external division on the right hand side of this particular point P, right? Had m been less than n, the point would lie over here. right? So that's something which you can observe clearly. For internal division, m equals to n implies point lies at this middle point. For external division, can we have m is to n equal to 1 is to 1? That will be difficult actually. So m and n, if you have an external point, if you have an external division point, then in that case, m upon n cannot be 1. That is one of the ways of dealing with it. Or you can say that m equal to n will be possible only if the point q actually goes to infinity. That's what you can observe. Oh, infinity from this side or this side doesn't make a difference. But you can see m is not equal to n for this point q is important to note, right? Otherwise, the point q will not be found, right? So that's all that you need in this particular idea, and now we can solve this question over here. What does the question say? First part. So let me mark the points first of all. Find the coordinates of points which divides the line segment joining points this and this. Okay, for this and this. A is -2, 3, 5. B is 1, -4, 6. +1, -4, 6. In the ratio first part is 2:3 internally. For internal division, the coordinates of point P will lie over here 2:3. So coordinates of point P will be for this 2:3. 2 into this, 3 into this, and you add them, right? That's what you're supposed to do. So 2 into 1 will be 2, 3 into -2 will be -6 upon 2 plus 3 will be 5. This is the x coordinate. The y coordinate will be 2 into -4, which is -8, 3 into 3, which is 9 with a plus, upon 2 plus 3, which is 5. The z coordinate will be 2 into 6, which is 12, 3 into 5, which is 15, upon 5, 2 plus 3. That's what you get, right? The coordinates of P will be -4 upon 5, comma 1 upon 5, comma 27 upon 5. Those are the coordinates of P. What about second part? In the second part, the person says, okay, 2:3 internally. So in case 2:3 internally are we talking about? So we'll be taking a look at this particular point over here, Q. Oh, why are we drawing Q over here? I said, if m is less than n, then the point will lie towards A, right? Okay. So 2 is less than 3, therefore this QA will be this, and this will be 3QB, right? That's what you can say. Okay. One more thing, please note this carefully, that this is not drawn up to scale, right? If this is 2, this is 3, that means this is 1. So actually Q will be double the distance over here, right? But there's less space, so I'm just drawing it like this, symbolic representation, not actually up to scale. Okay. So in the second part, what do I need? I need Q. The coordinates of Q can be found once again with the help of crossing. What are we supposed to do? 2 into this, -3 into this. That's one of the ideas. Upon 2 minus 3. Or you can deal with 3 minus 2 as well. How will we do that? 3 into -2. We can replace that mx2 nx1 by nx1 minus mx2 upon n minus m. Is that okay? Yes, that looks okay, right? That's not an issue. We multiply with minus in the numerator and denominator. Let's take a look at this question from the original aspect as we saw over here first. 2 into 1 will be 2 minus 3 into -2, which will become 6. Oh, this just becomes 2. Instead of 2 minus 6, we have 2 plus 6. Yes, that's the beauty of it. If you have found the internal point, then you can easily find the external division by simply interchanging these values. In the denominator, you'll have 2 minus 3, which is -1. The next point will be -8 minus 9 upon -1. How did you find that so fast? Let's again find it. 2 into -4 is -8. Minus 3 into 3 is 9. Then for the z coordinate, you'll have 2 into 6, which is 12. 3 into 5 with a minus is this, upon 2 minus 3, which is -1. This is what you'll have. Okay. What does this become? 8 upon -1 is -8. Minus 17 upon this will be 17. Minus 3 upon this will be 3. Those are the coordinates of point Q. Okay. I also said that we can cross it in another way as well. What's that? You can deal with 3 times -2 minus 2 times 1. That's also possible. 3 times -2 upon, -2 times 1 upon 3 minus 2. That's what you can do. So -6 and -2 will be -8 upon 1 will be -8, right? 3 times 3 is 9, minus of minus 8 will be 17 upon 3 minus 2, which is 1. 17. That's what you'll get. Similarly, the z coordinate, you can verify that easily. This is the complete solution for this particular question, as you can see over here. In question number 2, it is given that P 3, 2, minus 4, Q 5, 4, minus 6 and R are collinear. Okay. Given that these 3 points are collinear, can you find the ratio in which Q divides PR? Can you find the ratio in which Q divides PR? Okay. So what will we do? Let's first draw the diagram. P, Q, R. Just a random location, and we mark. When we are supposed to find the ratio, don't use m is to n. Simply use k is to 1. Right? Lambda is to 1 or k is to 1. K is to 1. Let's say PQ is to QR is k is to 1. Okay. Let this be the ratio. Point P is given 3, 2, minus 4. Point Q is given 5, 4, minus 6. Point R is given 9, 8, minus 10. Okay. And I am given the ratio is k is to 1. I have assumed that the ratio is k is to 1. If the ratio is k is to 1, then can I write, given P and R, can I write the coordinates of Q? Oh, but the coordinates of Q are already given. Yes, that's the key. You can write the coordinates of Q which are already given, right? So you will get an equation in terms of K. An equation, not exactly one equation, we'll get actually from X coordinate, from Y coordinate, from Z coordinate, we'll actually get 3 equations. Just one unknown. Oh, there are more number of equations, yes. There may be a possibility of inconsistency. What kind of inconsistency? Okay, we get one value of K from one equation, another value of K from another equation, another value of K from another equation. In that case, the points will not be collinear, mind you. For collinearity, the value of K from X, the value of K from Y and the value of K from Z should be same. And the person said, okay, these 3 points are collinear, then find the ratio. So obviously from X coordinate, Y coordinate, Z coordinate will get the same value of K. And if we do not get the same value of K, that means there is something wrong in the question. Okay, yes. So let's take a look at this one. Coordinates of Q, I already know them, that is 5, 4, minus 6, which will be equal to what? These will be equal to, let's note the X coordinate, K times 9, 9K, 1 times 3 upon K plus 1. This is the X coordinate. What about the Y coordinate? K times 8, 1 times 2, K plus 1. What about the next one? K times minus 10 plus 1 times minus 4, which is minus 4 upon K plus 1. These are the corresponding X, Y and Z coordinates. Let's find the value of K. Using which one? We can use either X coordinate, Y coordinate or Z coordinate. It is already given that PQR are collinear. So we can use any one for that matter. Let's use therefore 9K plus 3 upon K plus 1. This X coordinate is equal to that X coordinate 5 over there. That tells me 9K plus 3 is equal to 5K plus 5. What does that tell me? 4K is equal to 2, or K is 2 upon 4, which is 1 upon 2. This is what you get. K is 1 upon 2. So K is to 1 will be 1 upon 2 is to 1, or 1 is to 2 basically. That's what you will get, right? Okay. Therefore, find the ratio in which required ratio is equal to 1 is to 2. That's my required answer. But is that all? Is that all in this question? No. There are 2 important things that we need to discuss over here. What's that? Okay, we mark point Q as an internal point of P and R, and we get the ratio as this. We can mark the point Q anywhere for that matter. We are simply solving for the value of K. That's what we are doing. We obtain the value of K as positive. Okay, required ratio is 1 is to 2, and this is internal. This means this ratio is internal division. That also needs to be mentioned over here. Yes. Had you obtained minus 1 by 2 over here, that would simply imply that the ratio is 1 is to 2, but it is an external division. That's point Q lies outside PR. That's the simple meaning of that. You may have, since this is a linear equation, you may have obtained the value of K as negative. In that case, the value of k, if it is negative, you will get the ratio. The ratio is 1:2 only, but with a negative sign. If it is with a negative sign, here you will write external division. In that case, the position of q will not exactly be over here, it will be outside PR. So will we change that diagram? No, we will not change that diagram. Diagram remains same. At the end, when we write the answer, we write it 1:2 external division. That's the only thing that you need to do and keep in mind. Okay. Another important idea. What's that? We have already discussed this, but I am reiterating it. Should we check the values of k for y and z coordinate? They should come same, right? They should also come 1/2. If they are not 1/2, then there's something wrong in the question. Yes. Okay. So let's move on and check. Just checking. Check. The question is solved. We have already done and attempted the complete question, but let's check. 8k plus 2 upon k plus 1 is equal to 4 tells me that 8k plus 2 is equal to 4k plus 4. That tells me 4k will be equal to 2 or k will be equal to 1/2. Oh, y coordinate also gives us the same value of k. Yes, it should. Next, minus 10k minus 4 upon k plus 1 is equal to minus 6. That tells me minus 10k minus 4 is equal to minus 6k minus 6. You take 6k over here, it becomes minus 4k, this becomes minus 2, and it also gives me k equals 1/2, which is okay. This is just for checking. The y coordinate and z coordinate should also give the same value of k for points to be collinear. That's important. Right. So we could have used x coordinate, y coordinate or z coordinate to get the value of k. If k comes out to be positive, the division is internal. If k comes out to be negative, the division is external. That's the only important thing. And that's all that you need to know in this particular question. From the very beginning, let me reiterate once again. Ratio is assumed to be k:1. Do not take m:n. If we take m:n, will it make any difference? Actually, not much. But just that instead of a single variable, you will see two variables, and handling those two variables may be a bit difficult. Will it be difficult? No, it is not at all difficult. If you are well versed with calculations, it will not make much of a difference. Here, at this point, you will get the ratio m upon n is equal to 1:2, and you will directly write 1/2, and you will directly write 1:2 ratio, right? After that, you write the coordinates of the point, tuck and tuck. This is given, this is found as per k:1, and compare these two to get the value of k. Right? That's all. If k comes out to be negative, the division is external. And you can verify that for y coordinate, z coordinate also, since the points are collinear, the value of k will remain same. Right? That's what you can observe. That's question number 2 for us. Pretty simple, yes. Question number 3. Now, question number 3 says, find the ratio in which the YZ plane divides a line segment formed by joining the points this and this. Now, our concepts from the previous question will come into the picture. How? Let's take a look at this. Ratio in which the YZ plane, now YZ plane, let's say, okay, YZ plane, X, Y, Z. If you consider this, then the YZ plane is actually this type. This is the YZ plane. This is what YZ plane looks like. Ratio in which the YZ plane divides the line segment formed over the points. Point P is this. Point Q is somewhere here. Point P is -2, 4, 7. Point Q is 3, -5, 8. Let these be the points. Now in coordinate geometry in general, it is very important that you draw the diagram, right? If you can draw a good diagram, your work is half done. Let's say this is point R. Point R lies on the YZ plane. What's the important thing about YZ plane? Do we know the coordinates of any point on the YZ plane? No, not the complete coordinates, but do we know something about some particular coordinate? Maybe. So if any point lies on the YZ plane, it has Y coordinate, it has Z coordinate, but its X coordinate is simply 0. So point R will have coordinates 0, Y, Z. This form. The coordinates of point R will be this. Okay. What else? We are asked to find the ratio in which the YZ plane divides the line segment joining this and this. Let the ratio be k:1. Let the ratio be k:1. Is that okay? Yes. So this is all let. You can note if you want to write it in words. Let the ratio in which point R, 0, Y, Z lying on the YZ plane divides the line segment joining P and Q in the ratio k:2 is the ratio k:1. Okay. Can you write the coordinates of R? R is already known to us. Okay, it is 0, comma, y, comma, z. Just the x coordinate is known, but don't you think so? Is that it is all that is required? Let's take a look at this. How? Since the ratio is being asked, we can easily write the coordinates using k is to 1 and p and q. So k times 3, 1 times minus 2 is 3k minus 2 upon k plus 1. K times minus 5, 1 times 4, minus 5k plus 4. Z coordinate, k times 8, 1 times 7. These are the coordinates. Our target is to find the value of k somehow, and don't you think so that you can easily find the value of k by using this 0 along with this? What about y and z? We are not interested in that for now. We are only interested in the value of k. So therefore, 0 is equal to 3k minus 2 upon k plus 1, which tells me 3k minus 2 is equal to 0. That tells me k will be equal to 2 upon 3. Since the value of k is positive, therefore the division will be internal. Therefore, required ratio is equal to 2 is to 3, and in the bracket mention that it is internal division. That's a required answer for this question. Is that all? Yes, that's all for this particular question. But let's say somebody else comes and asks, okay, can you also find this point R? Find this point R, what do you mean? We are already aware of the x coordinate, but can you find the y and z coordinate as well? Yes. How can you find that? The y coordinate will be equal to this. Also, question is done up till this point, but also y is equal to minus 5k plus 4 upon, and now I know the value of k, so let's use that over here. Minus 5 into 2 by 3, that's minus 10 by 3 plus 4 upon 2 by 3 plus 1. What's that? 4 into 12 minus 10 is 2. Divided by 3 will get cancelled. This becomes 2 plus 3, 5. This is the y coordinate. And z is equal to what? 8k plus 7 upon k plus 1. What is that? 8 times 2 by 3 plus 7 upon 2 by 3 plus 1. What's that? 8 times 2, 16. 7 times 3 is 21. 21 and 16 added to 37 upon 5 is what you get. And from here, yes, you can note that point R will be 0, 2 by 5, 37 by 5. That's my required answer for this question as it is over here. Is that okay? Yes. But is that all in this question? No. There's a small catch over here. Small catch? Yes. In case I'm asked to find such a kind of ratio, I can do it directly as well. Directly? What do you mean by directly? Do you see the two x coordinates? Do you see the two x coordinates of the given points P and Q? Minus 2 and 3. And do you see similar numbers over there? Similar, yes. 2 and 3. Okay. So will YZ plane divide P and Q in the ratio of x1 is to x2 with a minus sign? Yes, this is always true. How can you be so sure? Let this be x1, this be x2. Do you observe that this will be k times x2, this will be k times x2, this will be plus x1 upon this, right? K times x2 plus x1 upon this, and equal to 0, k times x2 plus x1 equal to 0, what do I get? K times x2 plus x1 upon k plus 1 equals 0, that tells me k will be equal to minus x1 upon x2. So YZ plane will always divide the line segment joining P and Q having coordinates x1 comma something, x2 comma something in the ratio minus of x1 upon x2. We have derived this now. Oh, should we remember this? You can, always, right? Since we have derived this, you understand the logic behind this, right? You understand the logic behind this is very simple, right? And memorize this for any next question, right? For YZ plane, mind you. Similarly, if you are talking about XZ plane, in XZ plane, the Y coordinate will be 0. So we'll be interested in Y coordinate. Y1 is to Y2 with a minus sign. That will be the ratio, right? In XY plane, the Z coordinate will be important. Minus of Z1 upon Z2 will be the ratio. Simple, yes, pretty simple. That's what you get over here. Okay. That's a complete solution for this third question and everything related to that. Okay, moving on to the next question. Question number 4th says, using section formula, show that the points A, B and C are collinear. Okay. If we want to show that the points are collinear, we simply should show that in the question before the previous question, we saw the ideas. Given the points are collinear, the ratio will be K, K, K. K will be same for X, Y, Z coordinates. The converse is also true. If K is same for the 3 coordinates, then the points will be collinear. Yes, that's what we'll be using over here. That idea will be using over here. What does the idea say? Using section formula, show that the points A, B and C are collinear. What are we supposed to do? Simply mark points A, B, C. First of all, take the ratio of B, K is to 1. Note the coordinates of B using K, and for X, Y and Z, you can easily find K, right? If K comes out to be same, for X, Y, Z, you can be sure that the points are collinear. Because K is to 1, AC will be divided into some particular ratio and you get the coordinates of B. That will be same as this, right? Yes. So let's begin with 2, minus 3, 4, 0, 1 by 3, 2, minus 1, 2, 1. By the way, to simplify calculations, you could have taken B here and C here as well. But doesn't make a difference. We can deal with this as well. So the coordinates of B are minus 1, 2, 1, or you can write them in terms of K as K times 0, 1 times 2 is 0 plus 2 upon K plus 1, comma, K times 1 by 3, 1 times minus 3 is K by 3 minus 3 upon K plus 1, K times 2, 1 times 4 upon K plus 1. This is what you can do. Yes, this is what you can do. Pretty simple, right? And now, can you find K? Yes. Let's use X coordinate. Minus 1 is equal to 2 upon K plus 1. That gives me K plus 1 is equal to minus 2. K is equal to minus 1. Sorry, minus 3 is what you're getting, right? Okay. K equals minus 3 is what you're getting over here. Division will be external. B divides AC externally in the ratio. This is 3:1 external ratio, right? This implies 3:1 external division. AB is to BC, right? That's what you can say. Or for the y coordinate, 2 is equal to K by 3 minus 3 upon K plus 1. That tells me, okay, this becomes K minus 2 is equal to K minus 9 upon 3 times, this is K plus 1 by the way. And this tells me, okay, 6K plus 6 is equal to K minus 9. That tells me 5K is equal to minus 15 or K is equal to minus 3, which is minus 3 upon 1. Same as this, yes. Y coordinate also is okay. 1 is equal to 2K plus 4 upon K plus 1. That tells me K plus 1 is equal to 2K plus 4, or this tells me bringing K over there, K is equal to 1 minus 4, which is minus 3. Just this, okay. Okay, yes. Since the value of K is same for X, Y and Z, you can clearly say that point B divides AC, line segment AC in the ratio 3:1 externally. And since point B divides the line segment AC in this ratio, obviously B will lie on the line joining AC. Therefore, A, B, C are collinear. Hence proved. That's the complete solution for this fourth question, as you can see over here. For the fifth question, find the coordinates of the points which trisect the line segment joining the points this and this. Okay, not bisect but trisect. Trisect. Is it difficult? No, not at all difficult. We have point P, 4, 2, minus 6. We have point Q, 10, minus 16, 6. For trisection, we need point R and point S as well. For point R, this ratio is 2 is to 1. How did you observe that? This is 1 is to 1 is to 1. This becomes a 2 is to 1. For S, once we find R, we can use a simple idea. What's that? This ratio is 1 is to 1. Once you find R, you can find the midpoint of P and R, which is simple. x1 plus x2 by 2, y1 plus y2 by 2, z1 plus z2 by 2. That's what you can do, right? That's pretty simple. Okay. Let's focus and find R first of all. For finding R, we are given the ratio 2 is to 1. So R will be, the coordinates of R will be, as you can see over here, 2 into 10, 20, 1 into 4 upon 2 plus 1. The y coordinate will be 2 into minus 16, minus 32, 1 into 2 plus 2 upon 2 plus 1. 2 into 6, 12, 1 into 6, minus 6 is minus 6, 2 plus 1. This is what you get. So therefore, coordinates of R, 24 upon 3, minus 30 upon 3, 6 upon 3, 8, minus 10, 2. This is what you get. These are the coordinates of R. Now, S is midpoint of PR. Therefore, coordinates of S will be midpoint of PR, P and R, 4 plus 8 by 2, 2 minus 10 by 2, minus 6 plus 2, 6, comma, minus 4, comma, minus 2. So the points of trisection will be points of trisection. 6 minus 4 minus 2, and the other one 8 minus 10, 2. That's my required answer for this question over here, as you can completely see the solution over here. With this, we come to the conclusion of this particular exercise number 12.3 from the chapter Introduction to Three-Dimensional Geometry from your class 11th textbook. Till the next session, all the best.